the example 13 in polynomials. This is an example of factorizing. As I mentioned earlier, we have two ways to to factorize a given polynomial. This is the given polynomial 6x square minus plus 17x plus 5. So this polynomial can be factorized by the splitting method or by the factor theorem method. You can use any one of those. The splitting method is you guys are already familiar with, and it's easy. So we'll try with the splitting method first. First we'll try with the splitting method. The given equation is 6x square plus 17x plus 5. Um, so we know the two factors. If we can find the, we have to split the middle term. Okay, so the middle term, the sum of the middle term should be 17, and the product should be 6 into 5. Okay, that is 30. The product should be 30 and the sum should be 17. So we have to look at the factors. So let's say 30. So 10 and 3 is a okay, 10 and 3 won't do. Let's say the 10 into 3, no, it's not adding up to 17. Then 15 2, yeah, 15 2 works, right? So we can use these two factors, 6x square and 2 should come first. Okay, so then only we can bring the common terms outside, plus 2x, and the next is plus 15x plus 5. 3 1, yeah, correct. So this is the order, so you should bring the 2x term first instead of bringing the 15. So let's take the 2x common, so we'll be left with 3x plus 1 plus and let's take 5 again, 3x plus 1. So it amounts to 2x, this 2x plus 5. That will be the first factor, and the second factor is 3x plus 1. So this was quite simple, straightforward, and we find the two numbers which is going to give the sum and product, and we use them as we split the middle term based on that, and we found the factors, right? The second one is going to be a little bit tricky. Okay, let's start with the second method, the factor theorem method. Using the factor theorem method. So first step is, let's say we are given with 6x square plus 17x plus 5, right? So first step is, step 1 is to find whether if this is a x square is a multiple of 1, right? But in this case it is a multiple of 6. So what you have to do is you have to divide the whole equation by 6, right? Or bring the common 6 outside. Six into x square, 17 by 6x plus 5 by 6. So So this becomes the 6 into this is our p of x. Our x square term should be in terms of 1. Okay, so that's why we are pulling the 6 outside. Now we have the constant term, that is the AB is equal to, this is the constant term, AB is equal to 5 by 6. Okay, so based on this we have to find the factors. So let's find the factors for AB is equal to 5 by 6. So this is by so the factors are plus or minus 1 by 2, plus or minus 1 by 3, this into 5 by 3, right, gives 5 by 6. This into 5 by 3. This one into 5 by 2. Okay, so these are all the factors because this is a multiple of this. Okay, and let's do this. And what else? 5 by plus or minus 5 by 3 plus or minus 5 by 2 plus or minus 1. 1 is always going to be a factor for all the things, right? So let's evaluate now. Let's find one by one now. Okay, P of let's start with plus P of 1 by 2 is equal to 6 into 1 by 2 whole square plus 17 by 6 into 1 by 2 plus 5 by 6. 6 into 1 by 4 plus 17 by 12 plus 5 by 6. Four threes are 12. 4 threes are 12. 3 ones are 3 plus 12 are 17 plus 6 twos are 12, 10. So that's going to become 10, 27, 30 by this gets cancelled. 2s are the numerator we have 10, 27, 30. 30 by 2, that is equal to 15. So not equal to 0. So this is not a factor. Okay. So let's try the minus 6 into minus half whole square plus 17 into minus half plus 5 by 6. 6 into minus half by 1 by 2 whole square, the same thing, 1 by 4. This become minus 17 by 2. 17 by this is 17 by 6. So this becomes 17 by 12 17 by 12, and this becomes 5 by 6. 6 into 12 LCM, 3 minus 17 plus 6 to the 12, 10. Six 2s are 12. Then we have minus 14. This becomes minus 14 plus 10, that is minus 4 by 2, that is minus 2, not equal to 0. Therefore, p of minus half is also not a factor of the given polynomial. So now let's try with let's try with p of minus 1 by 3. Okay, so that will give 6 into minus 1 by 3 whole square plus 17 by 6 into minus 1 by 3 plus 5 by 6. So 6 into minus 1 by 20, sorry, square, right? Square term, so 1 by 9, and this becomes minus 17 by 6 3s are 18 plus 5 by 6. So we have 6 into, let's take a LCM, 18 minus 2s are 18 minus 17 plus 6 3s are 18, 3 5s are 15. 15, right? So let's see, and yeah, this guy when we square it, this is going to become positive term. Okay, so with that, so 2 minus this becomes 0, right? So the whole term, as this becomes reduces to 0, the whole term is 0. Therefore this is a p of x minus 1 by 3 is a factor, so we can write it as, so x plus 1 by 3, right? X is equal to minus 1 by 3, x is equal to minus 1 by 3. So when this comes this side, it becomes x plus 1 by 3 is equal to 0. So this guy is a factor. Let's see what is the other factors we have. Okay, so we have to try with the other possible values, 5 by 3, 5 by 2, and so on. So I'm going to try with minus 5 by 2. P of minus 5 by 2, that is going to give me 6 into minus 5 by 2 whole square plus 17 into minus 5 by 2, okay, plus 5 by 6, again this by 6. So this is going to give 6 into minus becomes plus 5, 5 square 25 by 4 plus this becomes the denominator is 12 and 17 into 5 7 is 35, 85, 85 minus 85 plus 5 by 6. So we have 6. The LCM is 12, 4 3s are 12, 325 75 minus 85, 6 2, this becomes plus 10. Okay, so this whole numerator reduces to 0. Okay, so this arrives at 0. So minus 3 by 2 is a factor, therefore minus 3 by 2 is a factor, so we can write x plus 5 by 2 is a factor. Okay, so the equation is factor, given equation is factorized, so it reduces to, so p of x is reduces to 6 into the first term x plus 1 by 3 into the second term x plus 5 by 2. Okay, so if you take the LCM here, okay, so 6 into 3x plus 3 by 3, I'm sorry, 3x plus 1. 3x plus 1 by 3, and here it becomes 2x plus 5 by 2. So that will further reduce to, this becomes, right, this becomes 2 and we can get cancel this. Okay, so now it reduces to 3x plus 1 into 2x plus 5, same thing. Okay, so we have now understood the factorization method. The factorization method is based on the constant we find the factors, and we by trial and error method we find the factors one by one by finding the value of the equation for the particular value, and then we arrive at it. So it's a lengthy process, but sometimes it works better for some of the polynomials. For other polynomials, the splitting method is easier.